over a distance by an external force. So meaning, if we have an applied external force on an object, and then if it moves by a certain distance, then there is work done on the object. So in contrary, if wala nag-displace no ang object, therefore there is no work done on the object, although there is an applied force. And energy is defined as the capacity for doing the work. So this kinetic energy is a measure of the particle's capacity to do work, which is associated with the motion of the particle. So kaning work and energy nga method class no is just actually a technique that is adapted for solving frequently occurring problems in dynamics involving force, displacement, and velocity. So this method also eliminates the consideration of acceleration and leads directly to the desired solution. So in other words, kuan lang ni siya class mura og another way no or another method no in solving problems here in dynamics. So from our previous nga mga discussions no, so mao lang gihapon siya na mga problems, but another way no or another siya nga method in solving those problems. So the fundamental equation of this work and energy equation is actually based from the derived equations na from our previous discussion. Di ba we have the summation of forces equal to weight of the object over gravity multiplied by acceleration. And also the third kinematic differential equation, si ADS is equal to VdV. So if we will try to eliminate acceleration, so let's express acceleration in terms of summation of forces times gravity over the weight. No, so cross multiply lang siya. And substituting this expression of acceleration here in our second equation, so this will be summation of forces, gravity over weight, ds equal now to v dv. Then ako lang siyang i-simplify. So summation of forces, ds is equal to weight over gravity, v dv. So kani siya class no, kani siya nga term, mo na siya ang work. And kani po siya nga term, this refers to um, kinetic energy. However, this is the differential form of this work and energy equation. So if we will apply integrals, no, so we will apply antiderivatives to eliminate this differential form. So what will happen is from initial to s and initial to velocity, since we are the integral on the left side hand of our equation tells us to integrate with respect to s, and then ang right hand sa to ang equation is um, integrate no, with respect to v. So if we will treat the summation of forces as constant, since the forces no applied to a body are constant, so ma-let out na to siya sa to ang integrals, and then um ay, thank you Ma'am Ruth. Thank you Ma'am. Thank you Ma'am Ruth. Okay. So as continuation class no, ang mahitabo is summation of forces integral of ds, no? So integral of ds, then lower limits to upper limit. So ako na lang siya i-evaluate directly class na parang dili ra mo taas ang solution. So integral of ds is just s, right? Equal now to, so of course weight of the object is constant as well as the gravitational force g. So let out, then evaluate integral of vdv. So meaning may mo na siyang v squared over 2, no? Then initial to final. So what will happen here is summation of forces times the displacement is equal now to weight over gravity times evaluate this right side hand of our equation. So what will happen now would be 1/2 of final velocity squared minus initial velocity squared. Okay, so this is equal now to weight of an object over 2g times v squared minus initial velocity squared. And this is now our work and energy equation class. No? So, muna ilahang relationship. So, this term, ang left side hand sa to ang equation, muna siya ang work. No? So, if we will express or we will create a mathematical expression of the definition of work, work is just equal to the force multiplied by the displacement, Cs. No? And kaning 1/2 of Wg multiplied by the velocity squared, this refers to the kinetic energy. So, kaning kinetic energy, no, this will be expounded sa inyong hydraulic since magamit ni siya sa um, motion sa fluid, no, or sa liquid. So, ma-encounter pa din niyo siya sa pag-abot ninyo sa hydraulics po actually class. So, for now, we'll focus on our work and energy equation applied to our system of forces here in dynamics. So what does this tells us, no? Ang kanilahang work and energy equation. So this only indicates that um, the resultant work on a translating body is equal to the corresponding change in kinetic energy. Diba? So, ana lang na ang ilahang statement kibali out of this work and energy equation. So, like, sige, let us apply this principle or this concept to our sample problems. So, let's have situation 1. The 300-pound block rests upon a level plane for which the coefficient of friction is 0.20. So, find the velocity of the block after it moves 80 feet. So, starting from rest. And then the second condition given is that if the 100-pound force is then removed, how much farther will it travel? So if we will let our object no as a particle class. So initially, nasa laguraan nga point. So meaning ang iyang velocity dera no is just equal to zero since it started from rest. And then oops, it moved 80 feet no from rest. So we are asked to determine the velocity at this point. Ano siya, no? Find the velocity of the block after it moves 80 feet from rest. So, kano siya ang ipahita. And then the second condition is that if the 100-pound force is then removed, so how much farther will it travel? So, let's say this is point A and point B. So the second condition here is that after point B, if mawala ang 100-pound force nga incline that is acting on the object, so how much farther will it travel pa kaha? So, ana pa siya a certain distance nga na-cover. So if this is S1, which is 80 feet, so ato na siyang i-designate as S2, which is unknown, no? And then the velocity at this point, come point C, is just also equal to 0. Anong zero man? Kay nawala man tong applied force, no? Kani si 100 pound force sa ato ang system. So pag mawala na siya, mo na ang point sa problem, no? From point A to point B, there is an applied force nga si 100 pound force, and then pag abot kang point B nawala daw siya, so meaning kibali momentum na lang ang nagatuklod sa iyahan, no? Or ang naga-cause sa motion, and then eventually it will come to stop. So how much farther will it travel, no? Pag mawala ang 100 pound na force. So meaning at this point, at point C, ni-stop na siya, your velocity there is just equal to zero also, di ba? So mo ni ang nahitabo or ang motion kibali sa ato ang object. So first atong buhaton ani is let's just show the internal forces, no, that is acting on our object. So of course we have the weight of the object that is acting at its center of gravity. So 300 pounds. And then since it is in contact with a surface, so na siya gina-exert nga normal force. So how much is the normal force? So of course we'll just have to compute, no? So summation of forces on y-axis. So normal force is upward. So N minus 300 plus the y component of the 100 pound force, 930, equal na to 0. Therefore, the normal force acting on our object is just equal to 100 or 300 minus 100 sine 30, and it is equal to 250 pounds. So how much now is our resistance force, no? CF. Diba? It's just mu n. So asa man ang ato ang resistance force? So opposite sa direction sa motion. So if the direction of the motion is going to the right, so going to the left, no, ang ato ang frictional resistance nga force, and it is just equal to, so if this is 250, so 0.20 of 250 is just 50. So you have F equal to 50 pounds. Okay, so now that we have established the forces, na that is acting on our object, let us now analyze this using the working energy equation. So first, unaw sa nato ang first question, no, nga, how much is the velocity after it moves 80 feet? Excuse me. So unsa ganito, di ba, we have summation of forces multiplied by the displacement is equal now to weight over 2g times velocity squared minus initial velocity squared. So summation of forces, dito ta sum of forces sa axis of the motion, no? So always remember that one, class. So the axis of motion, since naman siya diri nag-occur, no, ang displacement or ang motion, so let us sum up forces on x-axis. We have unsa man nga mga forces ang naa kang x-axis. We have component of 100 pound nga force, and as well as si frictional resistance nga force. So sila lang duha, no? So this becomes 100 cosine of 30 minus 50, no? Since to the left ang ato ang frictional resistance na force which is opposite sa ato ang x component nga direction. So we take the direction of the motion as the positive convention. So multiplied by the displacement. So displacement of the block na from point A to point B is 80 feet. So this is 80 equal now to the weight of the object, which is 300 pounds, divided by 2 times the gravity nga 32.2 times velocity. So we are analyzing, di ba, from point A to point B. So meaning the final velocity would will be si V1, no? So V1 will serve as our final velocity in this analysis, and the velocity at point A would be our initial velocity, which is just equal to 0. So final velocity nga si V1 squared minus initial velocity nga 0 squared. So meaning, nasa to ang equation, no, isa ra ang unknown, which is si V1. So we can directly compute for V1. So how much is V1? Excuse me. So if we will simplify that one, we will be having sama na siya, 100 cosine of 30 minus 50 multiplied by 80 times the quantity of 2 times 32.2 all over 300, and then square root of the result. So V1 is just 25.072. Okay? Or simply you can just solve this by shift solve, no, sa calculator. Okay? So, 'di ba, we can also answer this problem, no, by the method or by the concept of the reverse effective force, CREF. So, pwede ra pod to siya. So, as I have mentioned earlier, this work and energy nga method is just another way, no, in solving problems here in dynamics. So, 'di ba, we have our discussion on our rectilinear translation with constant acceleration. So, kato siya, no, in consideration with acceleration. So, dinhi pod sa work and energy nga method, so eliminate niya ang consideration sa acceleration. So, ang involved lang yun, ano, no, is just the force, displacement, and ang velocity sa object. Okay, now, so the second condition sa problem, if the 100-pound nga force is then removed, how much farther will it travel? So meaning, class, we will now analyze the system from point A to point C. Diba? So from point A to point C. So we have to sum up the resultant work from A to B and B to C, and also we'll have to sum up the kinetic energy, no, that exists, no, from A to B and B to C. So inan ang mahitabo, class. So from A to C, the analysis and applying the work and energy equation equal now to W over 2G times final velocity squared minus initial velocity squared. What will happen now is ato sang i-analyze ang second phase sa motion class, no? So we'll have to understand kung unsay nahitabo. So then from A to B, di ba na pa man ang 100 nga pound nga force. Therefore, the normal force um, would be 250 pounds lang. So mao lang ni siya, di ba? The same lang. Kay the same naman nga condition, no, from our previous na solution, ang A to B. Karon kang B to C, so dara na di ba nawala ang 100 pound nga force. So meaning the only force that is acting on our system would be its weight na lang, no, nga si 300 pounds. So meaning ang normal force now would also change in magnitude. Kaya nawala man na nga to ang y component sa tong 100 pound nga force, kaya nawala man si 100 pound nga force. So the normal force now that is acting on our body would be 300 pounds as well. Di ba? And if the direction of motion is still, continue lang siyang sa iyahang motion, which is rightward, so the same lang, no, ang direction sa ato ang frictional resistance force. However, mo change ang iyahang magnitude. Okay? Ni-change man na nga to ang normal force, no? And our frictional resistance force is just dependent on the normal force. So, frictional resistance force now at B to C would be 0.20 of 300, and that is 60. So, mas need ako ang frictional resistance force, no, from 50 to 60. Okay? So, ato ang analysis kang B to C, we will use this figure, no, or free body diagram class. So applying the work and energy equation, we'll have, excuse me. So from A to B, so the same lang, no? Summation of forces multiplied by displacement. So 100 cosine of 30 minus 50 multiplied by displacement nga 80 plus, so kani siya ha, kang A to B lang ni siya. So summation of forces on B to C. So on x-axis, 'di ba, frictional resistance force na lang ang nag-act sa ang system. So meaning siya ra tong ma-include sa ang analysis, and since opposite siya, no, sa ang positive direction sa motion, so negative 60 multiplied by distance or displacement nga na-cover, no, which is unknown, no, muna si S2. So negative 60 multiplied by S2 equal now to the weight of the object, which is weight niya is 300 pounds, right? So 300 all over 2 times 32.2 multiplied by the quantity of final velocity minus initial velocity. So now, if we will observe, our velocity at point A is equal to 0, no? Kaya siya man na to ang initial point. And then, ato akong velocity at point C is equal to 0 since siya to ang final point, no? So, from initial to final, now, both points or both positions, the block is at rest. So, meaning, final velocity would be equal to 0 squared minus initial velocity nga squared. So, mag-0 lang ni siya nga expression, right? So, mo-0 lang ni siya class. Since any number multiplied by 0 would just be equal to 0. So, the right hand side of our equation is just equal to 0. Kani siya, di ba? So, if we will look at our equation, isa lang ang unknown variable, no? So, makomputer na to siya directly. So, 100 cosine 30 minus 50 multiplied by 80. So, this will be 2,928.203 minus 60 S2. Therefore, S2 is just 2,928.203 divided by 60. And S2 is just equal to 48.803. Okay? Excuse me. So, that's it, no, for situation 1. So, therefore, the velocity of the block after it moves 80 feet is equal to 25.02 feet per second, and it will travel 48.803 feet if the 100-pound force is then removed. So, questions or clarifications? So, wala. So, I hope na nasabtan siya, ha? So, sige, let's try another problem. So, let's solve sample problem number 2. So, I think familiar sa inyo ang figure, no? So, this is actually from our previous nga lecture pod. Ato po na siyang example, no? I think from week 13 ba to or week 15 na to nga discussion. So we have here the 300-pound counterweight B pulls the 200-pound block A up the 30 degrees incline. So the coefficient of kinetic friction is 0.20. So if the pulleys are considered frictionless and weightless, determine the velocity of block A after it has moved 20 feet from rest. So sige, ang ingon sa problem, no? Ang direction of motion is that the 300-pound 300-pound weight will go down while the 200-pound weight will climb up the 30 degrees incline. 'Di ba? So, naadri si displacement of P as well as the velocity of B. So, the displacement of A and the velocity of block A. So, sige. What we will be doing is first, we'll have to expose, no, the forces that is acting on the system. So, we have at 300-pound no weight. So, ang iyahang weight, no, ako na siya i-label as block B and then block A ni si 200-pound na weight. So, the weight of block B is just equal to 300 pounds. And then the weight of block A is 200 pounds. Okay. So, since block A is in contact with a surface, so naana siya normal force, no? And also, if the direction of our 200-pound weight, no, is upward, or if we will make this as our local x-axis, kibali, to the right, so meaning frictional resistance force na to is in this sign convention. Kani siya. So how do we solve for n? So it is just by summing up forces on y-axis equal to 0 at block A. So what we have here, so if we will make this as our local y-axis, so n, and then establish na to ang angle, no? So this is also 30 degrees, di ba? So if we have this triangle class, 30 degrees, and then si 200 pound na force, ang weight rather, and then ang y component nato, no? So, ang atong goal is ang y component, di ba, of black, of the weight of the object. So, meaning, um, si y and ang hypotenuse, no? So, adjacent and hypotenuse ang ato ang kuhaon. So, from SOHCAHTOA, it is by cosine function, no? So, cosine 30 degrees is just equal to the adjacent over the hypotenuse nga 200. Therefore, the y component of your weight 200 pound is just 200 times cosine of 30 degrees. So, negative sign convention will have negative 200 of cosine 30 equal now to 0. Therefore, the normal force is just equal to 173.205 pounds. Okay? So finally, we can compute for the frictional resistance na force since it is just mu multiplied by the normal force. So the coefficient of kinetic friction is 0.20 of 173.205, meaning the frictional resistance force has a magnitude of 34.641. Okay, so sige, let's start analyzing now the system. So ato sang i-relate po no ang displacement of A and B and also its velocity. So how do we relate that one? So SA is by the way given, no? Naa siya a displacement nga gihatag. So if mo displace daw ang block A by 20 feet, how much would be the displacement of point B? So if this length of the cord, no, is the displacement of block A, so meaning ang kana po siya nga length is equivalent ani kibali na length. So the displacement of your A is just equal to 2 times the displacement of B. So if this is the displacement of B, so 2 times SB, no? Ana lang siya. And if atong express ang displacement of B in terms of A, so may wala na siyang 1/2 of SA, 'di ba? So if ato pong ipakita no ang relationship sa ilang velocity, so all we have to do is differentiate this equation with respect to time. So we will have dsb over dt, that is velocity of b equal na to 1/2 since 1/2 is constant, then dsa over dt, so velocity of a. Okay, so naataan ni nga mga existing relationship no between your block A and block B. So what we will be doing next would be we will apply the energy work and energy equation, no? So unsa ganito, di ba? It is summation of forces multiplied by the displacement is equal to the weight of an object divided by 2g times velocity squared minus initial velocity squared. But since your block A, no, or the motion of your block A is dependent on the motion of block B. So we will analyze them as a system, no, or we will analyze them as one. So what we will be doing would be um, we will sum up the work done on block A and B, and also the energy that is done on block A and block B. So, di ba, this is work and this is the energy. So, if ako na lang siyang i-represent to as W and E, so, ang atong buhaton kay bali is the whole equation would be the work done on block A plus the work done on block B is equal to the kinetic energy on block A plus the kinetic energy on block B. Okay? So, ano siya? So, at block A, summation of forces on the axis of the motion or the displacement. So, ka block A, kinsa man ang nag-occur, no? So, naa kang x-axis, di ba, ang displacement? Meaning, we will analyze or we will sum up forces on x-axis. And what are the forces on x-axis? We have the frictional resistance ng force and as well as the x component of 200-pound force. So meaning, both of their directions now, since the direction of the x component of your 200 pound force is to the left and it is opposite, no, to the positive na sign convention, since ang motion is to the right side man sa ato ang x component or sa ato ang x axis. So this will become negative 200 cosine of 30 minus the f, which is 34.641, multiplied by their displacement. So SA is 20 feet, right? So this is 80. Ay, wait, 20 feet lang guys, sorry. Plus the work done on the object B, no, or block B. So if we will look at block B, what are the forces, no, na involved? So si weight B lang, right? And since the axis of the displacement is on the y-axis, so we will sum up forces on y-axis. And the only force that is acting on y-axis is the weight B, right? And it is positive sign convention since the direction of motion is downward man. So downward is positive here. And therefore, 300 times the displacement of SA daw kuno. So SA is 20 feet, so meaning SB is 10 feet. Di ba? So ana lang siya. So this is now 10 feet equal na to the kinetic energy on block A. We have the weight of block A divided by 2 times the gravity. So this is 200 divided by 2 times 32.2 multiplied by velocities, no? Final minus initial. So take note that the problem here states that it is from rest, no? So kibali, if we will look at block A only, initially na sa ani nga point and then it moved 20 feet daw kuno, no? So velocity here is equal to 0, no, since it is from rest. So how much is the velocity here? Muna ang ipangita class, no? So si VA. So therefore, VA squared minus 0 squared, no? Kaya initial velocity is equal to 0 man, plus the energy, no, exerted on block B. So weight of block B, which is 300 pounds, divided by 2 times 32.2 multiplied by the same, no? Velocity of B squared minus 0 squared, since initial velocity is also equal to 0, since the whole system it started from rest man, 'di ba? Sige, so ako lang i-simplify ang left side hand sa atong equation. So if you will simplify that one, we'll have the result would be 307.18 equal now to pila man ni siya, no? Si 200 divided by 2 times 32.2. This is 3.1056 VA squared plus um this one class, no? Kani si 300 over 2 times 32.2, 4.6584, no? VB squared. So, in this equation, duha to ang unknown variable, right? So we have VA and VB. So ang atong objective is si VA, right? So how do we relate VB to VA? So remember that we have this relationship also that your VB is just equal to the one half of VA. So meaning, if we will express VB in terms of VA, so this is just one half of VA, no, squared. So what will happen would be 307.18 is equal to 3.1056 VA squared plus 4.6584 multiplied by, so one half squared is 1/4 VB, other VA squared. Okay? So now, isa na lang ang ato ang unknown variable, di ba? So which means we can now finally compute for the velocity of block A. So VA. VA now therefore is pila man ni siya class 307.18 is equal to 3.1056 VA squared plus 4.6584 times 1/4 of VA squared. So how much is VA? VA is equal to 8.481. Okay? So I think mo naman siguro ni pangutana sa problem 2. No, determine the velocity of block A after it has moved 20 feet from rest. Okay, so therefore, the velocity of block A after it has moved 20 feet is 8.481 feet per seconds. So, questions or clarifications? Wala. I hope nasabtan siya ang ato ang concept, no, on work and energy equation. So I think that's it actually for this topic, no, or for this session. So I believe ako nang na-announce ang inyong final exam schedule. So ako lang yapon siyang butang sa ato ang PowerPoint, no, para ma-remind yun always. Okay? So the coverage of our final examination would be the topics no nga to ang na-discuss from midterm to find from midterm nga to nga week until sa to ang last topic which is kaning atong i-discuss today, work and energy nga equation. So questions or clarifications?
None so far, sir. Mag-raise lang
Ano,
if
sir?
ever may confusion, sir.
Okay, sige. So again ha, ato ang coverage should be on the kinetics of rectilinear translation as well as the curvilinear translation, then the dynamic equilibrium, banking of highway curves, the concept and characteristics na of rotation, and our discussion on rotation, then principle of work and energy. So kanina ato ang discussion today. So kato lang ang ato ang coverage. Okay? So if wala na questions na or kanas agali ang MDB. Mechanics. So, sa mechanics, ang atong exam sa mechanics is, so, umalay na ako na-announce sa inyo, no? Sige, ako lang i-post sa GC, no? Sa mechanics is June 17, 2022 from 8 a.m. to 12 p.m. So, half day ang atong exam sa mechanics. So, before tayo i-dismiss, let's just have your attendance first. So, kindly say present if you are here sa meet. Aberin Monique, Abrenica Hannah Grace, Asibar Maria Christine,
Present, sir.
Baniga Janelle Rose,
Present, sir.
Bonglai Joey,
Present, sir.
Kailing Joby,
Present, sir.
Econar Dondi, Flores John Aiki, Leoren Jeffrey James,
Present, sir.
Alagamba Christian Clint,
Present, sir.
Medalia Rosel,
Present, sir.
Riales Joyce,
Present, sir.
Hugo Ryan Van,
Present, sir.
Nahia, Nahia Lendi, Esperos Paul Vance,
Present, sir.
Oclarit Eliza Nicole, Ortiz Lord Vincent, Pacana German Martin,
Present, sir.
Perihan Jezreel Vincent,